Let's start with the basics. Gravity is the force that keeps us grounded, literally. It's what gives weight to everything in the universe, from tiny atoms to massive planets. But in space, gravity becomes a real pain in the astronaut's suit. It takes an enormous amount of fuel just to escape Earth's gravitational pull. In fact, about 90% of a rocket's weight at launch is fuel. That's like driving a car that's 90% gas tank. This is where anti-gravity technology comes in. Imagine if we could create a bubble around a spacecraft that negates the effects of gravity. We could lift off from Earth as easily as stepping onto an elevator. No more massive fuel tanks or multi-stage rockets. Just sleek, efficient spacecraft ready to explore the cosmos. But how exactly would this work? One promising avenue of research is electromagnetic propulsion. This involves creating a strong electromagnetic field that interacts with the gravitational field, potentially allowing for controlled levitation and movement. Another exciting possibility is the manipulation of exotic matter. Theoretical physicists have proposed that certain types of matter with negative mass could potentially create anti-gravitational effects. While this sounds like something straight out of a sci-fi novel, recent advancements in quantum physics are bringing us closer to understanding and potentially creating such matter. Now, let's talk about the game-changing implications of anti-gravity for space travel. First and foremost, it would make getting to space a whole lot easier and cheaper. No more need for massive launch pads or expensive disposable rocket boosters. We could have reusable spacecraft that take off and land with the ease of a helicopter. But the benefits don't stop at Earth's atmosphere. Anti-gravity technology could revolutionize how we move through space itself. Current spacecraft rely on brief engine burns followed by long periods of coasting. With anti-gravity propulsion, we could have continuous acceleration, dramatically reducing travel times between planets. Let's put this into perspective. With current technology, a trip to Mars takes about 7 months. But with continuous acceleration made possible by anti-gravity tech, we could potentially cut that down to weeks or even days. Suddenly, the entire solar system becomes our backyard. And it's not just about speed. Anti-gravity could make space travel much more comfortable for astronauts. No more bone density loss or muscle atrophy from extended periods in zero-G. We could create artificial gravity environments that mimic Earth's conditions, making long-duration space missions much more feasible. Now, I know what you're thinking. This all sounds amazing, but is it really possible? Well, while we're not there yet, we're making exciting progress. NASA and other space agencies are actively researching advanced propulsion technologies that could lead to anti-gravity-like effects. One promising area is the study of quantum vacuums. In quantum physics, empty space isn't really empty. It's filled with fluctuating energy fields. Some scientists believe we might be able to harness these fields to create a repulsive force against gravity. It's mind-bending stuff, but then again, so was the idea of heavier-than-air flight not too long ago. Private companies are getting in on the action too. Several startups are working on electromagnetic propulsion systems that, while not true anti-gravity, could provide some of the same benefits for space travel. These systems use powerful electromagnetic fields to create thrust without the need for traditional rocket fuel. But let's not get ahead of ourselves. While the potential of anti-gravity technology is enormous, there are still significant challenges to overcome. For one, the energy requirements for these systems are currently off the charts. We're talking about the kind of power that makes nuclear reactors look like AA batteries. There's also the small matter of our understanding of gravity itself. Despite centuries of study, gravity remains one of the most mysterious forces in the universe. We still don't fully understand how it works at the quantum level, which makes manipulating it a tricky proposition. However, these challenges aren't stopping scientists from pushing forward. After all, every major advancement in space technology once seemed impossible. From the first satellite to the moon landing, from the International Space Station to the Mars rovers, we've consistently broken through barriers that once seemed insurmountable. And here's an exciting thought. The pursuit of anti-gravity technology isn't just about space travel. The applications here on Earth could be equally revolutionary. Imagine frictionless trains levitating above their tracks, or construction cranes that can lift massive loads with minimal energy. The potential for transforming transportation, construction, and energy production is enormous. As we wrap up our journey into the world of anti-gravity, let's take a moment to appreciate the sheer audacity of this pursuit. We're talking about fundamentally altering one of the basic forces of nature. It's a testament to human ingenuity and our relentless drive to explore and understand the universe. While true anti-gravity technology might still be years or even decades away, the research being done today is laying the groundwork for a future that's beyond our wildest dreams. A future where the stars are no longer distant points of light, but destinations within our reach. So the next time you look up at the night sky, remember, those twinkling stars aren't just beautiful to look at. They're beacons of possibility, calling us to push the boundaries of what's possible. And who knows? With anti-gravity technology, you might just find yourself answering that call sooner than you think. As we continue to unravel the mysteries of gravity and push the boundaries of propulsion technology, one thing is certain. The future of space travel is looking up, way up. So keep your eyes on the skies, folks. The anti-gravity revolution is coming, and it's going to take us to the stars and beyond.